Hello friends, welcome back. In this tutorial we will study about CNF. The full form of CNF is Chomsky normal form. A context-free grammar is in Chomsky normal form or in CNF if its productions are of the form A derives A or A derives BC. It means a grammar is in Chomsky normal form if its productions have either a single terminal on their right hand side or they have two variables in their right hand side. For example, there is a grammar whose productions are given here as derives AB, A derives BS or A derives A, B derives SA and B derives B. Now, these are the productions of some grammar. Now see, in these all productions, right, the productions has either a single terminal in its right hand side or only two variables in its right hand side, right? So it means the grammar whose productions are these is in Chomsky normal form. Now suppose if there is a grammar G without empty productions, then this grammar G can be converted into Chomsky normal form without affecting its language. Now suppose there is a grammar G defined by a quadruple VTPS, where V is the set of variables, T is the set of terminals, P is the set of productions, and S is the start symbol. This grammar G doesn't have any empty production. Now what we have to do? We have to convert this grammar G into Chomsky normal form. So how we can convert it into Chomsky normal form without affecting the language of this grammar G? First of all, we will remove all unit productions from this grammar G. Now, how we can remove unit productions? This thing I have explained in previous tutorials. Now, after removing all unit productions from grammar G, what we have to do? We have to find the productions which are not in Chomsky normal form. Now the productions which are not in Chomsky normal form after removing all unit productions, they all will have a string of two or more than two symbols in their right hand side, right? Now what we have to do now? Now suppose there is a production A derives alpha which is not in Chomsky normal form. Here alpha will be a string of two or more than two symbols, right? Now what we have to do here? If there is any terminal A in this string alpha, replace it by variable XA and add a production XA derives terminal A and add this variable XA to set V, right? V is the set of variables of grammar G. Now see, for example, after removing unit productions from grammar G, we have a production A derives BA. Now this production is not in Chomsky normal form. So what will we do? We will replace the terminal B by XB, terminal A by XA. So we have got a new production. A derives XB, XA. And we will add other two productions also. XB derives B, XA derives A. and we will add these two new variables xb and xa to the set V. We will add these two variables xb and xa to set V, and this production A derives terminal B A will be removed from the grammar G. Now see in another example. Suppose this is a production A derives B A C B in grammar G, which is not in CNF. Right? Now what we have to do? Remove this terminal B by variable xb. Remove this terminal C by xc. Right? So we have got a new production A derives xb, A xc, B. Now remove this production A derives B, A, C, B. Add these variables xb and xc to the set of variables of grammar, that is V. Right? And add two new productions xb derives B, xc derives C. Right? Now after this, after performing this step, again check the productions which are not in CNF. Now the productions which are not in CNF, now after performing this second step, they will have a string of more than two variables in their right hand side. Right? Now what we have to do? Suppose there is a production A derives x1, x2, x3 up to xn. Right? Where x1, x2, x3, x4 up to xn are all variables. Right? Now this is a production having a string of more than two variables in its right hand side. So it is not in CNF. Right? So what will we do? We will add new n minus 2 variables in set V, because here in this production A derives x1, x2, x3, x4 up to xn. Right hand side of the production is a string of n variables. Right? So what will we have to do? We have to add n minus 2 new variables in set V. Like these variables are y1, y2, y3 up to yn minus 2. Now what will we do? We will replace this production A derives x1, x2, x3, x4 up to xn by these productions. We will replace this production by these productions. A derives x1, y1, y1 derives x2, y2, y2 derives x3, y3, so on up to yn minus 1. And the production for variable yn minus 2 will be yn minus 2 derives xn minus 1 and xn. Now see, it would be clear after this example. Now see this production. S derives A, B, C, D. Now this production is not in Chomsky normal form. Now right hand side of this production has 4 variables. So what will we have to do? We will add 2 new variables in set V of this grammar. Right? So we will add 2 new variables x1 and x2 to the set of variables V. and replace this production rule by these production rules. S derives A x1, x1 derives B x2, and x2 derives C D, right? So we will replace this production from grammar G by these three productions. Now see, these three productions are in Chomsky normal form. Now see, suppose there is a grammar whose productions are these one. Now we have to convert this grammar into Chomsky normal form, right? That grammar is G, which is defined by quadruple VTPS, where V is the set of variables, T is the set of terminals, P is the set of productions, and S is the start symbol. Now we have to convert this grammar G into CNF. This grammar G, see its productions. They don't have any empty production. So first of all, what we have to do, since it doesn't have any empty production, it can be transformed into CNF, right? We can convert it into CNF without affecting its language. So first of all, what will we have to do? We will have to remove unit productions. Now there is no unit production in this grammar G. Now again, check for the productions which are not in CNF. Now see this production. S derives AA and S derives BB. It is not in CNF. So what will we do? See, in this production, S derives AA. We will replace this terminal A by variable XA. This terminal in this production, S derives BB. Right, in this production, we will replace this terminal B by variable XB. Right, and we will add two new productions. XA derives A, XB derives B, right? And we will remove this production from the grammar G. Now, in place of this production, we will have four productions in grammar G. In place of these two productions, S derives AA, S derives BB. Right, because we have replaced these two productions by these four productions, right? And what else we will have to do? We will have to add these two variables XA and XB to the set V of grammar G. Now see this production. A derives A. This production is in CNF, but this production A derives A. It is not in Chomsky normal form. So what will we do? We will replace this terminal by the variable XA, right? And the production XA derives A is already in grammar G. So this production A derives A will be removed, and we will have a production A derives XA in grammar G. Now see this production B derives B. It is in CNF, so it will remain as it is. But this production B derives B. It is not in Chomsky normal form. So this terminal B will be replaced by the variable XB. Now in grammar G there is already a production XB derives B. Right. So this production will be removed. B derives B will be removed from grammar G. In place of that, we will have a production B derives XB BP in grammar G. Now see these productions. This production is in CNF. This production is also in CNF. This production is also in CNF. This is also in CNF. It derives A. This is also in CNF, but this is not in CNF. This is in CNF, and this is also not in CNF. So these two productions are not in CNF. Now we have to convert them into CNF. Now see this production. A derives XAAA. Right hand side of this production is a string of 3 variables. So we will add a new variable y1 to set V of grammar G. And this production will be replaced by these two productions. A derives XA y1 and y1 derives AA. Right? And this production will be removed from grammar G, and these two new productions will be added to grammar G, and this variable y1 will be added to set V of grammar G. Now see this production. B derives. Now see this production. B derives XBPP. It is not in Chomsky normal form because right hand side of this production is a string of 3 variables. So we will introduce, or we will add a new variable y2 to set V of grammar G. Right? And we will replace this production B derives XBPP by 2 productions. B derives XB y2 and y2 derives BP. This production will be removed from grammar G. In place of that, we will have 2 productions. Right? So after this third step, right, all productions in grammar G will be in Chomsky normal form. Thank you very much.